Hello students, welcome. Previously, lesson 3, form 3, topic 4, we were dealing with chemical properties of nitrogen gas and the uses of nitrogen gas. So today, lesson 4, we want to proceed to the compounds of nitrogen, where we are going to start the oxides of nitrogen. Specifically, our lesson today will be dealing with nitrogen 1 oxide gas, which is also known as dinitrogen oxide. So we're saying oxides of nitrogen are nitrogen 1 oxide, which we can write N2O, nitrogen 2 oxide, which we can write NO as this chemical formula. Then lastly, we're having nitrogen 4 oxide gas, which we can write NO2. Learners, remember, nitrogen is one of the elements that has variable valences. For example, when you're dealing with nitrogen 1 oxide, the valence of nitrogen is 1, and remember the valence of oxygen is 2. So when we interchange the valency, what we are going to get is N2O. So that means this is how we write or the formula of nitrogen 1 oxide. So the other name of nitrogen 1 oxide is dinitrogen oxide. So we're having 2 atoms of nitrogen and 1 atom of oxygen. So we can say dinitrogen oxide. So number 2, we are having nitrogen 2 oxide gas. That means then the valence of nitrogen in nitrogen 2 oxide is 2 and the valence of oxygen is 2. So when we interchange the valency and we divide the common factor, what we are going to get is NO. So this is the chemical formula for nitrogen 2 oxide. So the other name of nitrogen 2 oxide will be nitrogen monoxide. Then lastly, here we're having nitrogen 4 oxide. So in nitrogen 4 oxide, the valence of nitrogen is 4 and the valence of oxygen is 2 as usual. When we interchange the valency and we divide the common factor, how we are going to write nitrogen 4 oxide will be NO2. So that means the other name of nitrogen 4 oxide will be nitrogen dioxide, because we're having 2 atoms of oxygen in nitrogen 4 oxide. That's why the other name of nitrogen 4 oxide is nitrogen dioxide. So we go to the first oxide of nitrogen, which is nitrogen 1 oxide gas. And the other name of nitrogen 1 oxide gas, we said, is dinitrogen oxide, and its chemical formula is N2O. So let's start with laboratory preparation of nitrogen 1 oxide gas. So how are we going to prepare nitrogen 1 oxide gas in the lab? We need reagents. So we can use 2 reagents. One of the reagents, ammonium chloride, and we are going to mix with sodium nitrate. So those are our 2 reagents. The 2 reagents that we are supposed to use is sodium nitrate. We are going to mix with ammonium chloride. Those are our 2 reagents. Then we are going to heat the mixture of sodium nitrate and ammonium chloride. So what will happen when the mixture of sodium nitrate and ammonium chloride is heated? What will happen is that sodium chloride and ammonium nitrate will be formed. So when ammonium nitrate and sodium chloride is formed, we are saying next again, the ammonium nitrate formed is unstable. Therefore, it decomposes to produce nitrogen 1 oxide gas and also steam. So that's how nitrogen 1 oxide gas will be prepared in the lab. Next, we have to know how is nitrogen 1 oxide formed is collected. It is collected by a method called of a warm water method. We are collecting nitrogen 1 oxide gas of a warm water method. What is the reason why nitrogen 1 oxide gas is collected of warm water is that because it is soluble in cooled water. So if it is soluble in cooled water, we cannot collect it by over cooled water. Instead, we are going to collect it by over warm water method, because nitrogen 1 oxide is insoluble in warm water. So next, learners, let's check the reason why the round bottom flask is in slanting position or is set in a slanting position. It's in order to prevent water which condenses on the cooler part of the apparatus from running back into the flask and causing it to crack. That's the reason why the flask is set in a slanting position. So next, we are saying nitrogen 1 oxide can be obtained by strongly heating ammonium nitrate. However, this method is not recommended. So the reason is that because we are saying heating ammonium nitrate directly may lead to an explosion. So to avoid this explosion, that means ammonium nitrate is heated indirectly. How indirectly? That means sodium nitrate is mixed with ammonium chloride and the mixture is heated so that when sodium nitrate reacts with ammonium chloride, ammonium nitrate and sodium chloride is formed. So that means sodium chloride has no effect on heating, but ammonium nitrate decomposes on heating because it's unstable and forms nitrogen monoxide and also steam as the products. So we're saying ammonium chloride and sodium nitrate reacts to form ammonium nitrate and sodium chloride. So the equation for that reaction is sodium nitrate solution will react with ammonium chloride solution to form ammonium nitrate solution and sodium chloride solution. The next we are saying ammonium nitrate is unstable and decomposes to form nitrogen monoxide and steam. The reaction is ammonium nitrate solution. When we heat, we are going to get nitrogen monoxide gas and also 2 moles of steam. We are told note. Nitrogen monoxide is collected by warm water method as it is soluble in cool water or as it is insoluble in warm water. So next, let's go to physical properties of nitrogen monoxide gas. Number 1, we are saying it's a colorless gas with a pleasant smell. Number 2, we are saying it's slightly less denser than air. Number 3, we are saying it's slightly soluble in cold water but insoluble in warm water. So number 4, we are saying it has no effect on litmus paper, hence it's a neutral gas. Remember, learners, in Form 1, we have seen the types of oxides. We were having 4 types of oxides. One of them was basic oxides, acidic oxides, amphoteric oxides, and also neutral oxides. So an example of a neutral oxide is nitrogen monoxide. So number 5, we are saying it lights a glowing splint. Remember, learners, we are having oxygen gas as the gas that lights a glowing splint or that rekindles a glowing splint. Even that was the test for the presence of oxygen gas. The reason why nitrogen monoxide lights a glowing splint is that we are told the heat from the glowing splint dissociates nitrogen monoxide into nitrogen and oxygen. Therefore, the oxygen produced is the one that lights the splint. So next we are going to proceed to chemical properties of nitrogen monoxide gas. And we are going to go to number 1. We are saying reaction of nitrogen monoxide with metals. So we are saying when nitrogen monoxide is passed over heated metals, metal oxide and nitrogen gas are formed. Example, we are having when nitrogen monoxide is passed over heated copper metal, copper 2 oxide and nitrogen gas are formed. So let's write the reaction. The equation for the reaction, we are saying copper solid reacting with nitrogen monoxide gas. What we are going to get is copper 2 oxide solid and also nitrogen gas. So we are saying observation made, red brown solid changes to black. Reason, copper reacts with nitrogen monoxide to form black copper 2 oxide. The other observation, learners, is that a colorless gas is formed, and that's due to the formation of nitrogen gas there. So this is the setup that we can see when nitrogen monoxide reacts with heated metals. So here we're having nitrogen monoxide, and here is where we're having the heated metal. In our case, we're having copper turning, and here is where we are going to get nitrogen gas collected over water because nitrogen is slightly soluble in water. The second chemical properties of nitrogen monoxide is reaction of nitrogen monoxide with nonmetals, and we are saying sulfur burns brilliantly in nitrogen monoxide to form sulfur peroxide and nitrogen. So the equation for that reaction will be sulfur solid reacting with 2 moles of nitrogen monoxide gas. We are going to get sulfur peroxide gas and 2 moles of nitrogen gas. Next, we are going to go to the uses of nitrogen monoxide gas. And number 1, we are saying it's used as an anesthetic drug during dental surgery. Remember, learners, we are told nitrogen monoxide gas is also known as the laughing gas. The reason why it's also known as laughing gas is that because we are told patients recovering from dental surgery laugh hysterically. So for that reason, it is named the laughing gas. Number 2, it's used as an oxidizer in racing car engines and rockets. Number 3, we are saying it's used to produce flame for analytical work. Lastly, we are going to go to the extended questions. Learners, we have only one question. We are told, given nitrogen monoxide and oxygen, how can one differentiate the two? So kindly try it to answer. What is the difference between nitrogen monoxide and also oxygen gas? Remember, the similarity is that both of them rekindles or lights up when split. So what is the difference between the two gases? Thank you for watching.